Arduino functions. The functions allows a program to divide a specific code into various sections, and each section performs a particular task. The functions are created to perform a task multiple times in a program just by calling the function when needed. For instance, an engineer was set out to create the tallest building in the world. In order to get this enormous project done, he has to break down these processes into tasks such as drawing out the building plan, regulating the workers, concrete production, operation of cranes, etc. The allocation of teams, which comprise of experts, are necessary to take care of all these tasks. Let's take these tasks as the function in the program, while the teams which are responsible for these tasks are the rules responsible for the function to work. So the engineer has to call these different functions repeatedly in order to complete the project. To repeat a task multiple times in your code, we can use the same set of statements every time the task is performed. To repeat a task multiple times in your code, we can use the same set of statements every time the task is performed. The advantages of using functions. Let's discuss some advantages of using functions in your program. One, it increases the readability of the code. Two, it conceives and organizes your program. Three, it reduces the chances of errors. Four, it makes your program compact and small. Five, it avoids repetition of a set of statements or code. Six, it allows us to divide a complex code or program into smaller ones. Seven, the modification becomes easier with the help of function in a program. Function declaration, the method to declare a function. First, your function return type. We need a return type for the function. For example, we can store the value of a function in a variable. We can use any data type as a return type, such as float, int, char, bool, etc. Next, the function name. It consists of a name specified in a function. This represents the real body of the function. Next, the function parameter. It includes the parameters passed to the function. The parameters are defined as the special variable which are used to pass data to the function. Next, the function must be allowed. The function must be followed by parentheses and the semicolon. The actual data passed to the function is termed an argument. Here is an example of how to use a function. So, like I said earlier on when we started, the void setup and the void loop is just a function that has no return type. Okay, so just like a variable, a function can be declared with a data type of int, string, char, boolean, uh, long, double, float, and the rest of the data type you have. And there's something that function has that variable does not have. There's a data structure that is void, which will be seen, which will be seen on the void setup and void loop. The void simply means that these functions does not return any value. Okay, so it returns a null value, it doesn't return any value. So we'll be seeing about returns when we start. So this is a simple variable. Here's a simple function. So you type in your data type for the function or the return type for the function, which is int, and to return an integer of this function. Then the name of my function will be my add function. Okay, so here I open and close a bracket. So inside my bracket, I will type in my parameters. So parameters are just simply um variables that stores specific data on your function. So my first parameter, I create the variable int, which will be I want to store an int value, and the value of the variable name will be I. Then I add a comma, and now I say I create another variable int, and the name of my variable will be j. Okay, so since because it's the last variable, it's not going to have any commas. So this function has two parameters, which is two integer. Our parameters um give data to the function so that it can be manipulated. So we will see that closely. So after we've typed in our parameters, then you open and close a curly brace. So now inside our curly brace, okay, so let's type in a statement that should be saved inside the variable. Whenever the variable is called, these are the functions that's going to run. So I create a variable int, and then the name of the variable will be sum. So I just declare the variable. So now for me to manipulate my variable, I simply call the variable on the next line, which is sum. Then it, sum will be equal to an expression I plus j. Then I close statement to the semicolon. So next I type my return. So now I want to return the calculation I just made here. So I just call in the return keyword. So return, then I type in the variable I want to return, sum. Then I close statement semicolon. So now inside the void loop, or preferably inside the void setup, I simply call the variable. So I create some set of variable which is a. Then I'm going to assign a value to a. I'm going to assign 3 to a. Then I create another variable b. I'm going to assign another value to b. So a has a value of 3. Now I'll declare another variable, but I'm not going to assign any value to it. I'm going to assign a variable, and name is 6. So there's no value inside the variable. Okay, so here on a new line, I simply call the variable c. Then c will be equal to, then I call my function, my add function. So just like the way you call your variables, that's the same way you call your function. You must write the function name the exact way it was created. So my add function, so I open and close a bracket and then passing my arguments. So I created the variable a and then a variable b. Then I close the statement with a semicolon. Good. So I've done with the function call. So for us to see whatever values inside the function, I simply call the serial dot begin. So it's going to be 9,600. Then I close the statement to semicolon. Okay, so after I made an expression, after I called my variable, I'm going to put, so don't worry too much about serial dot begin or any of the serial method I'm calling. I'm going to explain more about that in when we begin working with them. So I now call my variable c. Okay, so I click on start simulation. Okay, so make sure when you type in your serial dot begin, your serial is always the S is always on capital letter, then the other words on small letter. So now you click on start simulation. Alright, so now if you look at my screen monitor is printing 9. So what you just simply did that is that when I called my function, it added 3 plus 6, which is 9. So let me explain how this function works. So first, before I went inside the void setup or the void loop, I created my function. So my function has a return type of int. So it can only return integer values. So that's values that are decimal. So the variable can return integer values. The next thing, which is the function name, is called my add function. You can see the camel case I used there. The next word, which is add, the first letter is capitalized, and then the third word, which is function, the first word is capitalized, which is F. So that is the name of my function, my add function. So next, I open and closed a bracket or a parenthesis. Then I created a variable. So that variable will sit there as our parameter. Whenever you call the function and you pass a value inside the function, that value gets automatically stored inside these two parameters. Okay, so for the first parameter, we created two parameters. You can create too many parameters, 10, 15, 20 parameters. You can create a lot of parameters. So depending on type of function you want to use, or the particular work the function is going to do with those parameters. So for this, I'm just going to use two parameters. I created a variable. So to store those values, you have to use a variable. So I created a variable of int I, and I use a comma to separate it, and then int j. Okay, so I created two parameters, integer I and integer j. Then I open and close a curly brace. So whenever you call this function and then you pass these parameters, whatever is inside the query brace is going to work just like your loops and your if statement. So whenever I call the function, I'm passing the parameters, the whatever is inside the query brace will work. So inside the query brackets, the first thing we created a variable. We declare the variable, and the variable data type is int, and then the variable name is sum. Then we put a semicolon. We just declare the variable. So the next line, we now made an expression to that variable. We call the variable name sum, then assign an expression, which is whatever is being given to I should be added to whatever value is given to j. So you just add these two parameters. Okay, then the next line will now be the return type. So now I want to return whatever result was given. So it will return whatever result was given, and then you type in the return keyword and then type in sum. So you want to return whatever result of the calculation. Okay, and so that calculation is stored in sum. So we have to call that sum variable. So the sum variable just actually gives us whatever calculation you make. Okay, so I believe you understand. First, we created a variable int sum, and then next we did expression to our sum variable, which is I plus j. Whatever is in I will be added to whatever is in j. We added the statement semicolon. Then the next line, we type in the return keyword and then we type sum. So it will return whatever result of a calculation is made. And that um result is stored in a variable sum. Your variable name might be different. So you just put in a variable name so that you print out to return the result of any calculation. Next, we went inside the void setup, and then we created the serial.begin to create a communication between the Arduino and the um, computer. So next, we created two variables, int a and integer b. So this integer a and integer b has a value of 3 and 6 respectively. So integer a has 3 and integer b has 6. Next, we now created another variable integer c, and then we didn't put any value for that because we wanted to store an expression there. So we just simply say c is equal to, then we call the variable name. We call the variable by typing the name. The same way it's been typed when you created the function. That's the same way you type it when you're calling it. So my add function, open and close the bracket, and then pass in this argument. So whenever you're passing data to your function, it's no longer parameters, it is now called arguments. Okay, so when we are creating the variable inside the bracket, we call that parameters. Whatever inside your bracket is called parameters. But now, when you want to now call the function, whatever data you pass inside the function is called argument. So then we pass in these two arguments, variable A and variable B, which has a value of 3 and 6, and then we close the statement with a semicolon. Then we now type in the serial dot print, and then we now want to print whatever is in C. So when you open the serial monitor, it simply showed us 6, because 3 plus 6 is it showed us 9, because 3 plus 6 is simply 9. Now I'm going to show you another way in which you can pass in arguments to the function. So, I used variables, so I can just simply remove uh, the variables I created here. Then I can now just type in the numbers directly to my function. So I just simply say 12, then add a comma, and then add 15 here. So I can just simply pass in the argument without saving it in a variable, because when I declared my function, it already has a variable. So whenever you pass anything there, it just automatically stores it inside that variable, which is int I and int j. So whenever value I pass inside it when I'm calling the function, it gets stored inside this variable, int I and int j. So now when I click on start simulation, then open my, so it just showing me 27, because 12 plus 15 is going to give me a result of 27. Okay, so you can see that now the process is a lot more smoother, because I am not making use of any variable. I just created a variable that we call the function in it. Okay, so I believe you now know how to work with functions. We'll be dealing with some functions, a lot of functions, when we begin our projects or begin working with some projects in Arduino. So this is a simple add function. I believe we now know how to use functions. So our next class will be on comments. So let's move into comments.